Hello students, in this lecture we are going to discuss about impurities. So last class I have explained about that trivalent and pentavalent impurities. So why it is called trivalent? Tri means 3. So the valence band has 3 electrons and penta means 5. So 5 electrons in the valence band. That's why it is pentavalent impurities or donor impurities. So for example trivalent impurities, that is group 3 atoms. And for example boron, if you take a boron atom, the last band or the valence band is filled with 3 electrons, and aluminium, that aluminium has 13 electrons, but look at the last band, it has 1 2 3, so it has 3 electron. And similarly gallium, that electron configuration is 2 8 18 and 3, so the last band is filled with 3 electrons. That's why it is known as trivalent impurities. Tri means 3. Pentavalent impurities, arsenic, that atomic configuration 2, 8, 18 and 5, the valence band has 5 electrons, and phosphorus has 5 electrons in their valence band, and similarly antimony 1, 2, 3, 4, 5. So these atoms are having 5 electrons in their valence band. That's why it is known as pentavalent impurities. Okay. So why should we study about the impurities? Because intrinsic semiconductor is not suitable for making electronic devices. So we need an extrinsic semiconductor. So that extrinsic semiconductor means based on the impurities, it is classified as N-type and P-type. So how we are getting P-type semiconductor? So you have to add a impurity with the pure silicon. So consider this is a pure silicon. So far it is an intrinsic semiconductor. Now I am going to add a trivalent impurity with the pure silicon. So for example boron. Boron is a trivalent impurities. It has 3 electrons in their orbit or a valence band. Now what will happen? This boron will chemically react with the silicon. It shares their valence band electron, and so here then one electron, we need one electron to get the stability. So here one electron is missing in this band, covalent band. So this is known as hole. Hole means there is an empty, there is no electron in that particular area, so that is a hole. So now neutral state or stability of electron is atom affected, because to attain a stability it needs 8 electrons, but 1 electron is missing, so there is a deficiency of electron. So the neutral state or stability state is affected. So hole means it is a positively charged. So this atom or this structure act as a positive. So impurity level or doping level means generally one impurity atom is added to 10 power 8 atoms of semiconductor or silica. For 10 power 8 silicon atoms you have to add one impurity. The purpose of adding impurity in the semiconductor to make it conductive. The missing of electron is known as holes. Missing of electron means that atom is positively charged. And each trivalent impurity atom provides one hole in the semiconductor, because we have added one boron, so one boron provides one hole. Similarly, if you add million and millions of borons, it will give millions of holes. And as an extremely small amount of trivalent impurity has large amount of atom, therefore it provides million holes of in the semiconductor. So that p-type semiconductor, so generally it is a pure silicon crystal. If I add one trivalent impurity, it will make one hole. If I add second boron, it will create second hole. Similarly, if I add million and millions of trivalent impurity, it will create holes. Holes mean empty space. So it is ready to accept the electrons. So each trivalent impurity atoms create one hole. The majority carriers are hole in p-type semiconductor. So if it is a p-type semiconductor, then the majority is a holes. So there is a deficiency in the electron. So that's all about the p-type semiconductor, and it is formed by adding trivalent impurity with the pure semiconductor. Holes are created inside the semiconductor crystal. These holes are positively charged, or the holes are ready to accept the electron. In p-type semiconductor, majority carriers are holes and minority carriers are electrons. So next lecture we will discuss about n-type semiconductor.